we'd like to try to find a Taylor polynomial for tangent of x. And if we take derivatives of tangent of x with respect to x, the first derivative is 1 plus tangent squared. And once we differentiate that, we get products and more derivatives come out. So differentiating directly is not that easy. And so we are going to resort to a little bit of a trick in some sense. We're going to think of tangent of x as sine x over cosine x. Now we know the expansion for sine of x, this is at base point equal to 0. And we know the expansion for cosine of x based at x equal to 0. And notice the first term in cosine of x is 1. So at 0, cosine of course is not 0. And so we can ask ourselves, can we find 1 over cosine, right? If we found 1 over cosine, then we would multiply 1 over cosine by sine, and we would get a polynomial for tangent of x. So what we'd like to do is to find a polynomial, 1 over cosine, so that when you multiply it by cosine, you get 1, right? I mean, this is pretty obvious, but it's not obvious that we should think of it in terms of polynomials. So again, what we're trying to do is to think of 1 over cosine as a polynomial that is defined by saying that when we multiply it by the polynomial for cosine, we get 1. And once we find that polynomial for 1 over cosine, we'll multiply it by the polynomial for sine, and we will get a polynomial for tangent of x. We're looking for a polynomial expansion for 1 over cosine x, and we're doing that by multiplying 1 over cosine x by the polynomial for cosine and getting 1. It's pretty obvious that the constant term in this polynomial should be 1, because 1 times 1 is 1. And of course, there'll be an error. There'll be a minus 1/2 x squared plus 1 over 24x to the 4th plus some order 6 terms. But those are smaller. They're higher order than the first term. Okay, if you follow that discussion, you realize that the next term should be 1/2 x squared, because if I multiply 1 by this, I get 1 minus 1/2 x squared plus something of order x to the 4th. And then when I multiply 1/2 x squared by this, I get 1/2 x squared, which cancels off this minus 1/2 x squared. And then multiplying x squared by x squared, I get something of order x to the 4th. And so that fixes that. Now the question is, what's next? And it's not so easy to guess. So let's call this constant c times x to the 4th. And then let's calculate, what do we have when we multiply this by the polynomial for cosine? Let's see, we get 1 times 1, which is 1. 1 times minus 1/2 x squared, which is minus 1/2 x squared. 1 times 1 over 24 x to the 4th. So, and then something times x to the 6th. So that was multiplying 1 by the polynomial for cosine. Let's look at what happens when we multiply this 1/2. We get 1/2 x squared times 1. Then we get minus 1/4 x to the 4th here. And then what's left is x squared times x to the 4th, which is already of order x to the 6th. So we don't actually care about that. And then when we multiply cx to the 4th by the polynomial for cosine, we get plus cx to the 4th. And again, when we multiply x to the 4th by x squared, we get something of order x to the 6th. So I guess we don't really need to add anything. And what do we want this? We want this to be equal to 1, right? We want the right-hand side, the product of these two, to be equal to 1. So obviously this is okay. The minus 1/2 and plus 1/2 x to the x squared terms cancel. And so we need to, C is going to be plus 1/4 minus 1 over 24. So that tells us what this coefficient is. We have found that 1 over cosine x is this polynomial, 1 plus 1/2 x squared plus 1/4 minus 1 over 24, which is 5 over 24, x to the 4th, and then plus something of order x to the 6th, meaning x to the 6th multiplying some polynomial. This is the polynomial expansion for 1 over cosine x based at x equal to 0. And sine of x, we already knew what it was. And tangent is the product of sine and 1 over cosine. So let's do that. If I multiply everything here by everything here, I get x times 1, which is x. I get x times 1/2 x squared, which is 1/2 x cubed. I have x times 5 over 24 x to the 4th. So that's 5 over 24 x to the 5th. And then I have x times something that multiplies x to the 6th. So I'm ignoring some polynomial that includes a factor of x to the 7th in it. Now let's continue. I get minus 1/6 x cubed times 1 is minus 1/6 x cubed. And then minus 1/6 times 1/2 x squared. So that's minus 1 over 12 x to the 5th. And then when I multiply this x cubed term by this x to the 4th term, I get an order x to the 7th term, and we're already ignoring those. And what's left is this 1 over 120 x to the 5th times 1. So that's plus 1 over 120 x to the 5th. So now we can add the coefficients. We have x. The coefficient of x cubed is 1/2 minus 1/6, which is the same as 3 6s minus 1 6, which is 2 6s, which is 1/3. The coefficient of x to the 5th, I'm going to get 5 over 24 minus 2 over 24 is 3 over 24 over here, and then plus 1 over 120. 120 is 24 times 5. So we had 3 times 5 is 15 plus 1 is 16. So 16 1/20ths x to the 5th. And of course we can cancel out the factors of 2 in both of those. Adding everything together, we found that tangent of x has the expansion x plus 1/3 x cubed plus 2 over 15. That was 16 over 120. X to the 5th plus terms omitted being x to the 7th and higher. Of course, this technique gets more and more cumbersome if we want to carry this out further and further, because writing the polynomial for sine is easy, but solving for the polynomial for 1 over cosine x becomes harder the further out we go. But in principle, we could go out to as high an accuracy as we wish to go.